Hi, I'm Bob. Welcome back to the solutions to the textbook Microeconomics Theory and Applications with Calculus, the 5th edition by Professor Jeffrey Perloff. We will start solving the exercises for the second part of the textbook from Chapter 11 to Chapter 19. The answers to the first part of the textbook from chapters 1 to 10 are already in my YouTube channel. I've put the link below in the description. Today, let's find the answers to Chapter 11, Monopoly and Monopsony. Here's exercise 1.1. You draw figure 11.1 for a competitive firm that faces a horizontal demand curve. Use the same type of reasoning that we used in figure 11.1 to explain why the competitive firm's marginal revenue curve is the same as its demand curve. The competitive firm faces a horizontal demand curve, as shown in the graph. Suppose the competitive firm's initial output is Q, and its revenue is area A, equal to P times Q. As its output increases by 1 unit to Q plus 1, the firm's revenue rises to the area of A plus B. The marginal revenue, which means the marginal increase in the revenue, equals A plus B minus A, which is B. Notice that the area of B is the product of P times 1, equal to the primes P. Therefore, the marginal revenue, MR, equals the market price P, which is also the demand curve the competitive firm faces. Let's solve exercise 1.2. If the inverse demand function is as follows, what is the marginal revenue function? Draw the demand and marginal revenue curves. At what quantities do the demand and marginal revenue lines hit the quantity axis? We have the inverse demand function. It is a function of price in terms of quantity. From the inverse demand function, we can write the firm's revenue function, R equals price times quantity, which is also a function of quantity Q. Finally, we take the derivative of revenue with respect to quantity to find the marginal revenue function. The inverse demand curve hits the quantity axis at 100, and the marginal revenue curve hits the quantity axis at 50. We find them by setting the price to 0 in the demand function and setting the marginal revenue to 0 in the marginal revenue function. Facing a linear inverse demand curve, the firm has a linear marginal revenue curve with a slope twice the slope of the inverse demand curve. Let's see exercise 1.3. If the inverse demand curve a monopoly faces is as follows, what is the firm's marginal revenue curve? We have the inverse demand curve, which is a function of price in terms of quantity. We can write the revenue function, which is the product of price times quantity. The marginal revenue is the derivative of the revenue with respect to quantity. Let's jump to exercise 1.4. Given that the inverse demand function is as follows. Derive the marginal revenue function. Compare the responding marginal revenue curve to the linear one, where C equals 0, and show how its curvature depends on whether C is positive or negative. From the inverse demand function, we can write the revenue and marginal revenue functions. We focus on the marginal revenue curve. To find the curvature of the curve, we need to find its slope and the change in the slope. The slope is the first derivative of the curve function, and the change in the slope is the second derivative. Here is the marginal revenue curve. In case 1, C equals 0. The first derivative is a negative constant, so the marginal revenue curve is linear and downward sloping. In case 2, C is negative. The first derivative is negative, and the second derivative is also negative. It means the slope of the marginal revenue curve is negative, and the change in the slope is also negative. It looks like this. The marginal revenue decreases in an increasing rate. In case 3, C is positive. The slope of the marginal revenue curve is uncertain, but the second derivative indicates that the change in the slope is positive. It implies that the slope of the curve becomes less negative or more positive as quantity increases. It looks like this. The marginal revenue decreases at a decreasing rate and then increases at an increasing rate. Let's solve exercise 1.5. Show that the elasticity of demand is unitary at the midpoint of a linear inverse demand function, and that a monopoly will not operate to the right of this midpoint. For a linear inverse demand function, P equals A minus B times Q. We can derive the elasticity of demand as follows by its definition. For the linear function, dP over dQ equals minus B. So the elasticity can be simplified as follows. At the midpoint, quantity is A over 2 times B. Finally, we can obtain the elasticity of demand at the midpoint, which is minus 1. To the right of the midpoint, the elasticity of demand is between minus 1 and 0. The same reasoning gives the elasticity of demand to the left of the midpoint, which is less than minus 1. In other words, the inelastic portion of the demand is to the right of the midpoint, and the elastic portion of the demand is to the left of the midpoint. The following is the reason why a monopoly will never operate to the right of the midpoint or in the inelastic portion. First, we write the monopoly's marginal revenue in terms of the elasticity of demand, epsilon. The marginal revenue equals price times the sum of 1 plus 1 over epsilon, Second, we find that the marginal revenue is negative in the inelastic portion and positive in the elastic portion. Third, we know that a monopoly chooses its profit maximizing output level Q star, such that the marginal revenue equals the marginal cost at that output level. Since marginal cost is always positive, marginal revenue should be positive too. In the elastic portion of the demand, the marginal revenue is positive. In the inelastic portion of the demand, the marginal revenue is negative. Therefore, the monopoly will operate in the elastic portion of the demand and never operate in the inelastic portion of the demand. Thank you for tackling the problems with me today. See you tomorrow. Thank you for watching this video and subscribing to my YouTube channel. See you next time.